lightning leader attachment to the ground or to a grounded object is one of the least understood and poorly documented processes of the cloud-to-ground lightning discharge. It is generally assumed that the attachment process begins when an upward moving light versus time waveforms at different heights above ground for a dark step leader in a negative flash triggered using the rocket and wire technique at Camp Landing, Florida. Large red negatively sloped arm indicates that overall downward progression of the leader. Light pulses associated with individual steps are numbered. They appear to originate at the tip of the downward extending leader channel and propagate upward. It is possible that two or more upward leaders are launched from the ground toward the descending leader, perhaps in response to different branches of the descending leader. An upward leader that makes contact with a branch of a downward leader is called an upward connecting leader. The so-called breakthrough phase is assumed to begin when the relatively low conductivity streamer zones ahead of the two propagating leader tips meet to form a common streamer zone. The subsequent accelerated extension of the two relatively high conductivity plasma channels toward each other takes place inside the common streamer zone. That breakthrough phase can be viewed as a switch closing operation that serves to launch two return stroke waves from the point of junction between the two plasma channels. One wave moves downward toward the ground and the other upward toward the cloud. The downward moving return stroke wave quickly reaches the ground, and the resultant upward reflected wave from ground catches up with the upward moving returning stroke wave from the junction point. The latter is the case because the reflected wave from the ground propagates in the return stroke condition channel and, hence, is likely to move faster than the upward wave from the junction point that propagates along the leader condition channel. When the waves bouncing between the ends of the growing return stroke channel decay, a single upward moving wave is formed. Thus, the lightning attachment process involves two plasma channels growing toward each other, initially in air and then inside the streamer zone. It is a matter of definition whether the very short-lived bidirectional return stroke wave should be considered a part of the attachment process or a part of the return stroke. There has been significant recent progress in our understanding of lightning processes. Much of that progress has been made possible via the use of relatively new tools, such as high-speed video cameras with frame integration times ranging from a few milliseconds to a few microseconds, and modern lightning locating systems. Also important is the use of rocket-triggered lightning as a partially controlled analog of nature's cloud-to-ground lightning.